So we have this function, p of t equals 50 plus 2500 t squared divided by 25 plus t squared, where p represents the population, t represents time. I think the word problem was talking about like population of frogs on a conservation or blah, 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 blah. You don't really need to know, right? That's why I don't like doing word problems, because we just need to extract what is it we need, which is basically the equation, and we need to know how our variables are defined. So the first thing is saying, what is the initial population? So, P of t represents the population of these, I'm just going to say frogs, population of frogs with respect to t. Well, obviously, if t is 0, that means that would be our initial, period. So if we want to find the initial of anything, we're just going to do p of 0. Obviously, I guess, your initial could start at a different time interval. But for our case, we're just going to have 50 plus and 2500 times 0 squared over 25 plus, I gotta sneeze, sorry. Oh wait, I can hold it. I got it. Okay. So anyways, as we put t 0, that's gonna make the numerator 0, and obviously when the numerator is 0, everything is 0, so that we can see that the initial population here is 50 frogs. The next one is finding the average rate of change on the time interval, I believe it was in years, from 1 to 5. Now, the important thing, I didn't remember which one was included or excluded, so I'll just kind of roll with that. But either way, if you remember the average rate of changes, that's basically the slope of the secant line. Now, I don't know what this curve looks like, right? But basically, this average rate of change is saying, all right, at 2 time intervals, we're going to have different populations. And basically, all we want to be able to do from there is find the slope. So if you remember, let's just kind of make something up. Let's pretend this is like an S-curve population. So here's like 50, right? Let's say it goes something like this, all right? So all I'm basically saying is, if we had here's 1 and here's 5, right? If we wanted to find the slope of that line, so here's 1, here's 5. Remember what that is that's the change in the run under the change in the rise, right? Or the change in the rise over the change in the run. So basically what we need to do is figure out what the rise is basically the y values. So what you're going to do is you're going to figure out what is p of 5 minus p of 1. Now, I told the student I'm not going to have time, I don't have a calculator. I'm not going to have time to calculate this, but I'll at least show you what to do. So just like I did p of 0, which was easy, you're going to do p of 5 minus p of 1, and this is, again, represents the, the average rate of change. And then just going to divide that by my change by run, which is 5 minus 1. And then obviously you just go ahead and figure that out, and therefore that's going to give you that approximation. There was another question which was what is the average rate of change at 3, right? Well, again, at 3 we're looking at an instantaneous rate of change, which basically means we're looking for the slope of the tangent line, which basically means we need to go ahead and find the derivative. So that's something that student would have been able to do based on their calculus, wouldn't have been able to find the derivative. And then there's another one with asymptotes, but without knowing the word problem, it doesn't really make sense for me to talk about it. I gave them some help that hopefully helps them